Chapter 25, Driving Forces of Weather. Section 25.1, Atmospheric Moisture. So the presence of water is vital to life on Earth. Water exists in three forms on the Earth. Liquid water, that's all in the oceans. You could have solid water, that's frozen in glaciers. Or you could have water vapor, that's present in the air, gaseous water. The concentration of the water vapor is called the humidity. It's just the mass of water vapor per the amount of volume of air, sometimes called the absolute humidity. On television, if you get a weather report, it generally contains a measurement of the relative humidity. The relative humidity is a measurement of the water vapor mass compared to the amount of water vapor that some air mass can hold. It's some percentage. Imagine that you are at home making Kool-Aid or sweet tea or something like that. You're mixing sugar into the bowl. There's only so much sugar that you can mix before the sugar remains at the bottom of the pitcher. The same is true for the amount of water in the air at some particular temperature. There's only so much water vapor that the air can hold. As the temperature goes up, the amount of water vapor that the air can hold goes up, and as the temperature goes down, the amount of water vapor that the air can hold goes down. So there's always some amount of water vapor dissolved in the air, but there's a limit to the amount of water vapor that the air can hold. And that limit is known as the saturation vapor pressure. And when you've reached the saturation vapor pressure, the relative humidity is 100%. The air can no longer hold any more water vapor. And the saturation vapor pressure varies with the temperature. The warmer it is, the more water the air can hold. The cooler it is, the less water the air can hold. So two processes are at work when water is dissolving in the air. Evaporation converts the liquid water to water vapor, and it's temperature dependent. And so in general, higher temperatures mean more evaporation. Condensation converts the water vapor to liquid water, and it's humidity dependent. It is reliant on there being some amount of water vapor in the air for it to turn into liquid. And the amount of condensation depends on the humidity. If the relative humidity is 100%, then there's going to be a lot of condensation. Any water vapor that's left over will have to be turned into liquid water. At the point where evaporation and condensation are equal, you have saturated air. If the evaporation is greater, the relative humidity drops, and you have a relative humidity less than 100%. The greater the difference, the lower the humidity, and the drier it feels outside. When the condensation is greater, the relative humidity is 100%, and there's additional water vapor that forms as liquid water. So as air rises to a region of lower pressure, it'll expand, and that expansion will cool the air. Likewise, warm air rises, but it has to do some work to expand, and it'll lose energy, and it cools. As the air cools, condensation becomes greater than evaporation. Liquid water forms in the air, and that liquid water will form on dust and salt particles in the air, which we call cloud condensation nuclei. These particles of liquid water will collect on these nuclei and form clouds. As these water droplets collect and grow on these nuclei, they'll become influenced by gravity and eventually will fall to the ground as precipitation, what we know as rain, mist, hail, snow, or sleet. And remember, this does not need to occur high in the air. This can occur at any level in the air. Condensation that occurs close to the ground can generate dew on leaves or your car in the morning. Clouds can form close to the ground and form fog, or in colder temperatures, condensation can form and freeze and form frost. On a cool night, when the temperature drops below a certain point, the air will become saturated and liquid water will form. If the dew point is at or below freezing, then you get frost.